Wow. We are live on YouTube, and it looks like the Wi-Fi is working.
Yay.
Cool. Okay. What is this called? The living room lab?
Yeah.
This is the living room lab. And we're going to try hooking the capacitors up and letting the electric scooter run off the capacitors and see what...
Instead of the batteries.
Instead of the batteries.
And the reason why we want to do this is because last time we were checking to see if the alternators would charge the capacitors, because there wasn't a lot of amps being pulled from the alternators. I think it was, how many amps were being pulled? 5?
5, yeah.
Yeah, so it wasn't very much.
5 from this side and 5 from this side.
Yeah, so we thought we'd go ahead and we went ahead and tested to see if it would fill up the capacitors, and it did charge the capacitors. So we're just wondering if the batteries are even charging fast enough for our system to work. So we're going to go ahead and take the batteries out, and I don't know if these capacitors have enough capacitance to keep to run the scooter, but
Yeah, they're 24 volt.
we need to charge these up first.
We could charge them off the alternators.
Yeah, so we have to charge them up. They're not charged right now.
They're only 1 farad,
Yeah, they're only 1 farad capacitors.
24 volt. Usually for car audio, the older systems.
Yeah.
What's the test we did where we ran? Yeah, that's when we spun the alternators with a drill, right?
To charge up the capacitor? Yeah.
No, I mean
so,
in
right?
no, I mean here.
Well,
in the
you
living
have
room
to
lab.
rephrase your question. I'm not sure.
Okay, so the test I did, that was had the batteries hooked up,
Yeah.
had the batteries connected to the alternators through the bridge rectifiers, and then we had the motor connected to the controller. So we had it basically without the capacitors. We were trying to run it, and I was spinning it with the... Is that how we did it? Oh no, we had it connected. We bypassed the batteries, didn't we? We were just running these wires from the alternators directly to the motor. Remember I did that test? And
I
was
don't know. We've
spinning
done so many tests.
just yesterday.
Yeah.
So what I did yesterday, just to run you through this, I ran the alternators, the power from the voltage regulators that gets from the alternators directly to the motor, and spun the alternators with a drill just to see what it would do. And we didn't get very much power. There wasn't a lot of power coming out.
Yeah. Yeah.
So I probably should have streamed that one.
It's okay.
that test.
That's all right. We were just getting situated in our living room lab.
Yeah.
So okay. So well, let's try charging up the capacitors, because that did seem to work when we charged them
Okay.
before. So yeah, let's do that first. Get them charged, and then let's see if the scooter will run, even though these are very low capacitance in comparison to, say, like the batteries. Then maybe we have some sort of possibly like an extended range system or something like that. I don't know.
Yeah.
It reminds me of the small circuit that we have been kind of working on with Creative Electron's circuit that we've been trying, because he used no batteries except to start the system, but the capacitors weren't charged up, right? So we're going to charge up the capacitors ahead of time and see if that works.
Okay.
Okay.
I'll get started
So
on
that's the
wire.
first step.
So unhook the batteries, plug in the capacitors.
Yes.
Okay. I'll work on that.
All right. Let me know if you need help.
Thanks. Are we gonna run the capacitors into the controller? Or you
Yeah.
want you want to run
Yeah,
to the
I want to
controller?
try that.
Okay.
So we're running right now, just so you guys know, we're running a 36 volt system. What happened to our charger for the 24 volt?
The charger,
Oh, something got shorted or
yeah, it got shorted.
yeah. So we did something wrong with that. So I think it was when we were resetting up our scooter, and I think the batteries were hooked in backwards.
That's what it was. Yeah.
So we don't have a charger for our 24 volt batteries. So we went ahead and we tried putting in the three batteries together for the 36 volt system. We put in the 36 volt controller.
Because we have a charger for that system.
We have a charger for that, so we thought we'd go ahead and put that in there. And since we're already set up that way, we thought we'd start with trying the 36 volts with the capacitors. So we'll wire those together in series, and we'll just fill them up. We won't go too high. We'll probably go 38 volts or so. And then that's how we'll start this one. We did try running it with we've tried it a couple times running it over voltage, and that seemed to be fine. The alternators got a little bit warm. I don't know if that's a problem, so we may have to come back down to 24 volts. But at least just to test, see if this is even going to work. If it doesn't work, I think we'll try the 24 volt. We should try 24 volts, I guess. Because it does seem that the alternators kind of have like a peak efficiency. Where's those charts? Let me find those.
Where were they? Oh, the charts.
Oh, let's see. I think
Oh, okay.
okay, so I'm gonna show you guys real quick. Let's see. Where's the lens? Let's see if we can. So you can see. Here we go. So you can see there's like a peak efficiency, and then it kind of levels off. So I don't know if it's gonna be really. I don't know where we're gonna hit that point.
So this is 2,000 RPMs right there.
Yeah.
That's pretty high up there.
Yeah, and that's about where we would be with the 24 volt system. So
Looks like it's around 18 amps on this.
and we don't have an RPM meter,
Yeah, 17 amps.
which we were thinking of getting that. That would be
Yeah.
helpful
Yeah, we
to
do
see
need that.
exactly how many RPMs we're running. But we'll just give this a shot, and because it's already set up this way right now. And if it doesn't work, like I said, we can always try 24 volts. And then if that doesn't work, we may need more capacitors. We have some more. We don't have, again, it's compared to a battery, it's not a lot of capacitance, but we're just going to see if this will work.
I need to be reminded of how to wire these.
Oh,
So normally, on a capacitor, here's the positive, here's the negative.
yeah.
I'm guessing the negative would go to like a ground, like a battery. Is that where that would go? Or would it go to like that ground? Because we're treating these as batteries, and on these actual batteries, we do have a positive and negative. So I can make
Yeah,
sure.
so on here, obviously for a series, right, you want to do positive to negative. How are the batteries hooked up right now to the controller?
Well, the way they were
Or-
hooked up is like this. See, this was going here, this was going here,
Yeah.
like that. Series to add voltage. So 12 volts each, 36 volts. So the way they wired is positive to this negative. Okay. This positive to this negative. So we have two batteries.
But I mean, so yeah, so you got two.
And then coming out, what completes it is us going positive and negative to the controller.
Yeah, so you do the same way with the capacitor. So positive. One would have a positive going to the controller, the other one have a negative going to the controller.
So like this, so this positive. Oh, I see what you're saying. So this
Yeah.
positive. Oh, it'd be just like this then. You're saying.
Yeah. Yeah.
I guess I'm just having trouble like seeing it because it's like these are screws and these are
Oh.
like my brain is just.
I know
like,
what you mean. Yeah.
It's just not working.
It's okay.
Because I've never wired them like on these before.
Yeah.
Okay, so let me see. Gosh, how do we connect? So I need to go from something like that would go to that. So I need something like this, I guess. Something that goes like this. I'll try to reuse what we have
Okay.
as much as possible. So this positive would go to this positive.
Uh-huh.
Okay, I'm going to tighten that since we know that goes there.
It is, so, oh, that's coming from the alternators, isn't it?
Yeah, that's putting these in parallel. That's the positive from the alternators, yes.
Okay.
From the bridge rectifiers from the alternators. Okay, we got that one.
The batteries were in parallel?
No, I'm saying the bridge rectifiers were in parallel. Here.
Uh-huh.
See, this is parallel.
Oh, I thought oh, I see. But going to the you're not saying that the capacitors are in parallel to the rectifiers, are you?
The capacitors. No. No, well, I'm gonna do the same thing to the batteries. We're gonna wire the so here.
Okay. Oh yeah, no, we're good. I see.
Yeah. I
see.
guess I just
Okay.
threw extra.
Oh, it's okay. No,
I said more than needed.
It's okay.
I think I said more than needed to be said, and it confused things.
It's okay.
Okay. So, and then here's our negative. So this negative will go to. You make things easy.
I do.
I was like, I don't know how to hook this up. I'm still learning the series parallels
I am too.
configurations.
So, we're both learning.
Well, I like how you used as a reference our batteries. You're like, well, the batteries are in series, so we should be able to put these in. It's just these look different. It's like, oh
Yeah.
gosh, they look different. So this will be negative. It does seem like we probably would want to use some super capacitors because those have
Yeah, I think so too.
a lot higher
Yeah.
capacitance.
What did you use in the in that extended range experiment? Was it
Those were super capacitor. Well, those were literally like 500 farad, I think, or 100 farad.
okay?
But the voltage was low.
The voltage was low.
So I don't know if we can get high voltage like 24 volts with also a high farad, or if that has to be a big capacitor. But we can get several small ones, 2.7 volt, run them in series to get the voltage.
Wait. Remember when we were talking about the lithium-ion
Yeah.
batteries? We could use the lithium-ion batteries from the RC cars
That's right.
and wire those together, because those should also be able to take a fast
charge. That's a good idea.
Yeah,
That's a good idea.
that might be better.
Okay.
Yeah.
So several companies make them for the 1/8 scale remote control cars.
Yeah.
They also have 1/5 scale remote control cars, but we'll have to see who makes batteries for those.
And the reason we were thinking of using those is because, oops, our camera's tipping. Oh my. I didn't know how you had it set there.
Yeah. It's not very stable.
Yeah, we need a better... Well, the way that we were thinking about that is because Joseph used to work with the RC cars and take them to the track and everything, and you had a really nice, like, kind of like a quick charger, right?
Yeah, it was by
it was what, 40 amps or something?
40 amp quick charger.
And that's like, for what we're doing with the alternators, like 40 amps should be good. So if they're able to if those batteries are able to take that kind of charge, then we're thinking of using those.
Mm-hmm.
And as always, like, if you guys have ideas or comments that you want to share, we don't have the comments on right now for the live chat, but you can still comment on the video and we'll see it later. So that's always appreciated.
Okay, let's see. This is so like confusing to me. Okay, let me see. I guess I could just replicate exactly what we had here. So look, see how we have two wires that were coming in, like the controller was going here to the same two that the bridge rectifiers were connected to. See?
Wait, what's going on?
I'm trying to copy this.
Yeah. Okay.
So I was saying that. Let me just show you. I'm just trying to see how to apply what was here to this. And
Yeah.
I'm having trouble.
Well, this is that's 3 batteries. Where's be 2 capacitors? So I don't know if it's gonna.
We're doing 3. Oh, you don't want to do 3 capacitors?
Oh, I guess we could do 3 capacitors.
Since we already have the controller for the 36 volts in there. I thought we were going to start with 3.
Well, the reason why I was.
Oh, because of the efficiency?
I don't know. I guess we can.
I mean, we're
yeah.
producing really high voltage.
But we don't need to wire these. Like, if these are wired in series, it's not going to really give us more. I don't think the third one is going to do anything, is it?
Oh, I see what you're saying.
Because we just need extra voltage.
Because these are 24 volts each.
We're not going to get more capacitance by wiring them all in series, right?
Yeah, I forgot these were 24 volts.
Yeah, so we don't.
So
need
we only need 2.
We only need 2.
That might make things simpler.
Okay.
Let's see. Let's still see if we can figure this out now. Okay.
Well, you need to.
So let me.
You need a way to connect to the controller.
Yeah. Let me put these back where they were.
Okay.
Just so I can have a reference.
Think of wiring these together like the way that you would for the 24-volt batteries.
Let's see. This isn't giving me a very easy path to plug into here. The 24-volt batteries. Okay. Okay, so the way I had this wired was both of the bridge rectifiers were going to the same place that the controller, this is the controller, is going to.
Yeah, you're gonna need that. You're gonna need to take out that whole prong.
So
just that whole section there.
Just take this whole thing off.
Yeah.
Right?
Well, hold on a second. Yeah, make sure the batteries are connected. Alright. Yeah, just like that.
And then this one too.
Mm-hmm.
So now the batteries are totally not connected to anything except each other.
Yeah, so then basically where you had these, so maybe take this off.
Well, maybe I can just go into
Or
here.
I see, go into there, yeah. That makes it easier.
Right?
Yeah. There you go.
And then this one would go here, right?
Yeah. And then connect these 2 capacitors together.
Right there.
Yeah. Mm-hmm.
And that should be series.
Yeah.
That should give us, that should add the voltage of these 2, so it should give us 48 volts, 24 each.
Mm-hmm.
Right? Okay. Connecting those 2.
So the way we're going to charge this is just by turning the alternators with a drill. And you said that's going to help not to weld.
Oh yeah, because if we charge these, like let's say we just touch a fully charged battery
Yeah.
to these. When we were doing that in the past, it was throwing like an arc weld.
Right.
Because they just pull all the power at once.
Yeah.
If I'm saying it right, like
Yeah.
it was sparking. But since we're going to charge them slowly with these alternators turn, as they turn from a low RPM, they produce more and more.
Uh-huh. Then it won't do
volts.
that.
Yeah, so it won't do that. Tool. It might be in here. Yes, it is.
So just crimping together another connector. There we go.
It should. Okay. Now I think that one is long, but we're going to leave the wires long for now, while we're still trying to figure stuff out.
Yeah. Yeah, that's fine.
We'll connect this one. To this one. And this should add voltage, add the voltage over these two because we're in series. Positive. Let's see. Well, that's positive. Negative should be over there somewhere.
Yeah. Or it's just maybe just the positive.
They just have positive. So positive, negative. And this should be, that's positive, negative. Okay.
Good.
Series. Capacitors wired in series. Okay. Let's see what we can do. Oh, I'm bumping the camera.
The cord?
Yeah. I see what's happening.
Ah.
Oops.
Uh-oh. Sorry,
yeah,
guys.
It's not stable at all.
Okay, we don't have a stable overhead camera here.
We'll improve that.
Yeah.
Okay, let's see if it holds. Okay. Yeah, it's not very stable there. Oh gosh, it's not staying. Is there something heavier we can use?
That is not a good thing to use.
Is there something?
We need some sort of sandbag or something.
Yeah, that's what I was just saying. Is there something
Yeah.
heavier we can use?
Actually, here we go.
And you said the words. You said
I've got, look, ankle weight.
Okay, this is gonna. It's funny how you said that. You're like, we need like a sandbag.
There we go. Let me see if maybe it'll work.
Yeah,
On top of them.
it'll hold our selfie stick, right?
We've got a selfie stick coming off of a bookshelf.
Thank you.
Alright.
This definitely helps stabilize our camera.
Much better. I never thought I would use those for that.
Yeah.
Okay, great.
How's that look? Is that good?
It's pretty good.
It's a lot more stable now.
Yeah. Alright, so the camera shouldn't fall anymore.
Okay, everyone. So this wire here is just.
Thanks for bearing with us.
Okay, let's see what happens here. Let me tighten these up. Okay, make sure wires aren't touching each other. That's the controller. Oops, this just came unplugged.
Uh-oh.
Seems like it's loose. Let's see. Probably should tighten that a little bit. Okay, now everything's pretty tight. These are good. Let's see. No, that's loose too. Let's tighten that one. Just make sure it's loose here. Oh no, this one's good. That one's good. Okay, it just wasn't on all the way. Okay, so that's that. Okay, these are tight. I need to find my other Allens. Oh, that's not tight right there.
I think they're outside.
Okay, because this is not the right size. I'll look for them later when the sun gets a little lower. It's a little hot out there right now. Okay.
Hot day in Los Angeles.
Yeah. Okay.
Yeah, hence the noisy air conditioner in the background. Sorry for that.
Okay, so basically we're going from alternators. Let's see if we can show those real quick. Alternators over there, there's 4 of them, to the bridge rectifiers, to the capacitors, and the batteries are not being used right now. Okay, let me get the drill.
Okay,
And here's this.
so we're gonna need a meter to make sure we don't go too high with the voltage as we're charging up the capacitors. Did you put the meter away? Or?
It's up there.
It's is it
moved
connected?
so it's easier to see.
To-
Yeah, it's connected. I got
it's
it
not.
connected.
Okay.
Yeah, I'll connect it. I'll connect the meter. Just take one of these out. This is our positive, so that'll go to.
So these are coming from our meter. These wires, the white ones. Okay. And this black one is also coming from our meter. Let's get the meter in the shot here. If we can. So
maybe over here. That light's going to try to reflect in your lens.
I see. Let's see if we can.
Can you
That's
stay
good.
like this here?
Oh, so I just didn't want to get in the way of the wires there.
Oh. Let's see.
Okay.
Oh, it's going to be shaking a lot
Oh.
because the whole
I'll just hold it.
shakes. Okay.
Okay.
Okay, powering up. No, we're not powering up. Oh wait, we are. Wait a second. How are we doing? You want?
No, we're not gonna do that. We're gonna.
We're plugged into the controller.
Oh, we're plugged into. We're gonna charge. We're just gonna spin this, right? This
Oh, to charge the capacitors. Then.
Yeah, we need to charge them.
Okay, got it. Okay, thank you.
Okay, so we're just taking a drill.
So glad that you're reminding me of stuff, the obvious. Reminding me of the obvious. So right now the capacitors are at 12.5 volts. Let's charge them up with the alternators, right? That's
Yeah.
what we're doing. Okay.
Okay, so.
So
Here we
right
go.
now we're just charging the capacitors with alternators.
Okay, stop. That was stop. I think the drill is working a little too hard. It's kind of hovering at 34 for some reason.
Should we do a test with the? Should we see what's coming out? Should we unplug the capacitors and just see what's coming out of the alternators?
I guess.
Okay.
Okay. Can you help me put the camera back?
Yeah.
Okay. Thank you. Set this down. Okay. Okay, so you're gonna unhook
I'm gonna unhook the meter.
very carefully.
Oh yeah, I'm gonna unhook these,
Okay.
the capacitors.
All right.
And then we'll leave these hook. We'll leave the hook in. Should I unplug? Well, for now, I'll just unplug the capacitors, I guess.
Yeah.
And we'll try it. We'll leave the controller plugged in for now. Yeah. Because that might be pulling something too. But we can do our first test with just the capacitors unplugged.
Well, I just don't know why it wouldn't charge above 34.
I don't either. I just want to see what's coming out of the capacitors to see if it's even putting out more than 34.
Okay.
Because that's the only reason. That's the first thing to look at. I think is what's going into.
Oh, wait a minute. Yeah, these aren't really. I don't think those are meant to go that high, really. You
Well,
know?
there's no regulator on them. They're just producing voltage
Yeah.
without restriction.
Okay.
Yeah, they're made to make. I mean, I don't know what they're made to make, but there's
Yeah.
no voltage regulator on them. This is gonna smell. It doesn't mean it's hot. It's anything's wrong with it. Like they get hot. This is actually easy for us to turn these. This thing's
Okay.
made for drilling like way harder stuff than turning alternators.
All right.
It's just gonna smell because it's like the brushes in there.
Okay. Got it.
Okay, so we're gonna check our voltage.
Okay, so now this is going to be measuring the output of the alternators.
Okay, ready?
Right? Yeah. Okay, ready.
It's hooked up. Yeah. Okay. Here we go.
That's interesting. So it's producing less voltage than what we got into the capacitors?
The capacitors increase the voltage somehow.
That's weird. And
Neat,
cool.
right?
Yeah.
By how much? Couple volts?
2 volts.
Okay, that's interesting. I want to try. So what were we at right now? What was it at?
It was at 32.
Okay, let's
Point
try
something.
unplugging the controller and just see if it goes higher. I'm just curious.
Okay.
So I'm just going to unplug the controller. In fact, I'll do it over here. I'll just unplug it right here.
All right.
We gotta be careful not to let wires touch each other.
Yes. Very careful.
We do have 2 charged capacitors here, so
Yeah. have to be very
these wires shouldn't even be near anything, probably.
Yeah.
Let's get those. I'll just bend those away from everything. Okay. All right.
Okay.
Yeah, interesting that they increased the voltage.
Mm-hmm.
Okay, let's see what it's at now. This is just with all we did was unplug the controller. Okay.
All right.
Okay, so that's interesting because these were producing 20 volts each, and we tested them individually.
I see.
So we should be. I thought we were at 40 volts when we tested them in the garage.
Yeah, I think so too.
So I don't know why the voltage is lower now.
I don't know. Was that with or without bridge rectifiers in place?
Oh. That makes sense. 32. If we're losing like 1.5 volts each through the bridge rectifiers,
Yeah.
there it is, right? That's how much
Yeah.
we're losing.
So it's 32. It's still low though.
It's still low voltage.
I mean, are we actually losing 1.5 or are we losing more?
1, 2, 3, 4,
Because this
5,
might
6.
this might actually be like more like 2 volts or something. like that.
Okay. Yeah,
But
it
it's
could be.
still kind of low. I mean, if it's 32, it would if it before it was at. Oh wait, no. Yeah, 36. It should be at least. It should actually be at least 36. With the if you guys were getting 40, where you were getting 40 volts with
We can try it right now. And
wait, hold on. So you were getting 40 volts with the 36 volt system? Is that what was going on? Or like what? Or just spinning, free spinning with sorry. So you were
Yeah,
free
just free
spinning.
spinning.
Okay. And that was how much you got out of it. All right, I see. That's strange. I don't understand that. Maybe more powerful drill, I guess.
Oh, yes.
That's probably the difference then.
So, it was spinning it faster.
Yeah, it was probably spinning it faster.
Okay, that makes sense. I
So,
forgot about that.
so okay, so with this drill, that's as fast as we can.
That's right.
So I don't. Should we try? I mean, we can only get these at 34 volts.
You know what? Since we're here,
Yeah.
let's try hooking up the. Do you want to try bypassing the controller and running the alternators from here, the DC from the bridge rectifiers, directly to the motor and spin it with the drill and just see what happens? Because last time I did that test last night with the batteries, and it didn't do anything.
Yeah, it didn't do anything.
But now, if we bypass the batteries and go to the capacitors, I am a little curious what it might do.
Yeah, we could try
And
that.
it's easy to do. All I do is hook this into here. Let's see.
Yeah.
Let's
Okay, so
unhook.
just be very careful.
Okay. So I'm gonna unhook here.
Okay, so we're gonna try bypassing the controller. But isn't that just gonna spin it right away? When you hook it up?
Yeah, but then we'll bring it back. You're right. In fact, I have to discharge the. Thank you for saying that. How can I discharge the capacitors right now?
Where's those little meter things? They're in
The meter thing?
the.
Oh, they do it naturally.
Yeah, they do.
Okay. Yes. Thank you. Excellent idea. I never thought of that. You're like, let's use the thing that's made to do that.
You want to show everybody what we have?
Yeah, these came on the capacitors. They were on them.
And they discharged the.
Yeah, they were.
capacitors.
The voltage was dropping fast, and I'm guessing these were discharging. So let's. I guess all we do is touch there and there.
Okay, so
Let's see. Let me put some clothes on.
yeah.
I know they all didn't work, so if this one doesn't work, I'll try another one. Let me try this one first, though. I can't believe we can stream with the Wi-Fi. We couldn't do that before. It's really great. Okay, so this is the plus, so I'm going to touch it on here. Oh, wait, we got
We got a bunch of.
I got to disconnect
I
one
would
of these.
disconnect those.
That's too much voltage.
Yeah.
It's not made to discharge 40 something volts. Well, let's see what the voltage is at. Curious. Just want to see what the voltage is at. Wow, there's 30 volts in there.
There are.
On both. In the capacitors.
Wait a minute.
What?
I have an idea.
Okay.
Well. I was gonna say we could just try one. If there's 30 volts in each.
No, there's 30 volts total.
Oh, 30 volts total.
Yeah.
Oh, okay. I was gonna say, wow. Never mind. Scratch
Okay.
that.
All right.
But I do think we should. Obviously, we're not gonna be able to use that 36 volt controller, right?
For the test. Oh, you mean ever?
We're gonna bypass it right now, but I think
Right
the
now,
next,
right.
the next thing I think we should try is this 24.
Okay, we can do that.
Yeah. With the
Oh, weird. It just started saying very bad connection.
Oh,
It's-
as you said.
I
you
know.
said.
It seems like it just, like, I don't know if that actually has any, like, it's really,
I don't know what this is losing.
it just seems like it always says that.
Yeah.
Here, let me take it off. I'll just take it off here. I'll take these off.
Yeah.
Oops, I bumped the camera. Ooh. Gosh, that scared me.
Yeah, this is.
I saw it flying around. I'm like,
Yeah.
oh, man.
Sorry.
This thing's going to arc something.
Yeah.
These are they throw a much bigger spark than the battery because they dump everything at once.
I know. Okay.
Guess we could take this one off. Good thing that's a negative.
Still. It's a good habit. Whether it's positive or negative.
I'm just saying, I'm glad it wasn't a positive.
Yeah.
I'm not glad that it hit anything. I'm just, if it had hit something positive, it would have been arcing.
Oh, I thought you were saying because I grabbed it.
No, I'm saying I'm glad it was.
Oh.
I don't think it'll hurt you. It'll do anything to you
Yeah.
unless you arc it. Remember we arced it?
No, I know.
Yeah,
I
yeah.
remember.
Yeah, and it
I
burned
remember
you.
well. Do you want me to go? Oops.
I got it. This one's short, so I can hold it myself. Okay.
Okay. Alright. Okay.
Oh, now I got to discharge it. Okay, so I'm going to touch this on there and see.
What was that?
We're going to see if this will bring the voltage down. I'm touching it. one might not work.
That one might not work.
Let's try this one, see if this one works positive.
Yeah, it does.
That was weird.
Okay.
I don't know why it did that. Why
That
it
was
hard.
weird. It's not supposed to do that. Great.
Glad I had gloves on.
Huh? Yeah.
It's acting like the polarity's reversed. I mean, it says positive right there. Unless there's different.
What happened? Oh,
The
are you
polarity
supposed
could be different because I don't know the cap goes to this.
Oh, I see.
You could have just like burnt the whole circuit board on the feet.
Probably did.
I mean, it doesn't matter.
Did you put it back in there? Because
Yeah,
if it's broken, I want to keep it out. And I want to get rid of it.
We'll have to figure. I don't know which one it is. No, we'll have to figure it out later. I mean, do you want to keep doing? I don't know.
Like, well, hold on a second. Is there a way to see?
No.
No. I don't know. Shoot.
I mean, we could just I can just arc them. I can use a tool and just touch it. And, you know what I mean? Discharge it like that. Because we're discharging it because we don't want to make the motor spin.
Hold on a
Right?
second. You don't want to use this because you want something with a handle. You know, like this isn't good. That'll go to you.
Well, I don't think it'll shock me.
Well, I would use something different. I would use like
Okay.
a screwdriver or something.
Okay.
Um,
Yeah, I can use a seat.
huh?
A seat. It's a bar. That bar. No?
I don't know. Did it already discharge?
It looks like it's already discharged. This one's probably got something in it though.
Is that metal gonna?
You know, it's got
Where's let me get a screwdriver.
one that you don't mind it getting really messed up. I could use these. No, that's probably won't work. Let me see if anything's
Oh,
even in
hold
it.
on a second. I know what this is. Here. Doesn't.
Yeah.
Here.
Still has 14 volts in it.
How much?
Yeah, they each have 13 and 14. 13, 14.
Wait a minute. That's perfect.
Is it?
Yeah. Because then we're gonna do 24 volts, right?
Yeah.
Yeah. Just wire them back up.
And connect it to.
Wait, what was the next thing we were gonna try? Oh, we were gonna try bypassing the controller.
Yeah.
Okay, yeah. Just
Oh, wait a second. Why don't we use the controller, and then we can run them all the way down that way.
all right,
we'll
yeah.
put
So
the
now
24
they're at
We'll do the 24 volt controller.
yeah, they're like at 26, 27,
Yeah.
and that's okay. Right?
Yeah.
'Cause that's about where the batteries go.
Yeah. Yeah.
Okay.
Okay.
All right.
So,
So that kind of sort of worked, but
all right. So I'm gonna change the controller to the 24 volt, right?
yeah.
Okay.
Okay. So if you need a screwdriver,
Yeah.
these are. Fine.
Okay. Thanks.
Definitely don't use just straight metal stuff.
Okay. Okay. Here's our 24 volt controller. It's annoying that this plugs in so far down there. Oh, am I pulling the phone? This one goes to that. This one goes here. I gotta make sure I don't plug this charger in now.
Okay,
No.
we'll put that away.
capacitor's back, so the controller's in. I do have.
I'm gonna go to the bathroom.
Okay. Yeah.
Where did you put the leather safety glasses?
Which other ones?
The ones that were scratched.
I'm still wearing them. There was none in there.
There was none in there?
No.
Oh, I guess.
They're all outside, yeah. I was like, wow, I'm glad I didn't throw them away. Unless they're way in the bottom. I didn't look all the way down.
Yeah, there's some in here.
Is there?
Yeah, there's actually a number.
Oh. Okay.
Some in here.
Oh, wow. I just have to look further.
Yeah.
Thanks. Okay. I'm glad you checked. Thank you. Whoa!
What?
I can see. Here, let's throw these away.
Okay.
Try looking through those. They're so bad.
They're not much different than the ones on.
Oh, we need more. We need new ones then.
Yeah.
You want to wear mine?
No.
Okay, so what I'm thinking about doing is going into here and putting these fittings on. I think I might need to take more of that off. Oh no, let's see. Let's see if there's enough. No, it looks like there's enough there.
Like my gloves?
I do. Very nice. Okay. Yeah, there's enough there, huh? Enough wire in there. Yeah. Okay. Okay. One more. Okay. That's good.
Okay.
Now we'll go. Okay, wait. Oh,
You need.
are we using the controller right now? Yes, we wanted to discharge the
Well,
capacitor.
did you just you put in the 24-volt controller?
I did.
Okay, great. But yeah, let's try it. Let's try it with the controller. I think we should try it with.
And then when we run it, we could run the capacitors all the way down. We could run them down, and for the next test, it'll be discharged.
Unless it stays charged.
That works too. If it stays charged, I'll be happy too. If it stays charged, we will have smiles bigger than the ones we have now.
Joseph,
What?
you need to plug the capacitors in, don't you?
Yes, I do. Thank you.
It's not gonna work without them.
Yeah, I need capacitors. Thank you. Need capacitors.
Okay, let's be really careful.
Yeah, I'll put them over here.
Okay, well there's metal here too. So
Thank you.
downward. Okay.
Okay, capacitors are coming in. Here they come. Bring in the capacitors. Okay. 2 big capacitors. Okay. Where's the wires? For those?
The
Yeah.
pliers?
The wires? Are down
I
here?
thought you said pliers. Yeah, put them in here. There's all these.
Okay. I don't need all of them.
Okay.
Like, I don't need this one. I don't need that. Okay.
Okay. And wires, extra wires.
Use this. Wait a second. Yeah. This one, this one. Oh. Oh, are we going in series again? Yeah, we're going in series, right?
Yes, we are. Same
Okay.
thing.
Same thing. Same thing, same place. Positive to negative. Positive to negative. Oops, sorry.
It's okay.
Okay. And then the other ones, this is going to be positive to positive over here. I'm going to go ahead and hook it in first.
You need to move these
But
so that it's closer.
I don't think so. Let's see. Looks like it's good there. Yeah, see?
Okay.
Thanks, though. Oh, I see what you did. What is this? Okay. Capacitor is connected on one side. This, I think this is the other one's the negative onto negative. Okay.
All right.
So this one will come around like this.
Okay.
So the wires go. Go ahead and connect this now. And then connect this here. Let's go with this
Okay.
one here a little bit. Okay.
So we're wiring up our 24-volt system with capacitors. We've got our controller hooked back in, our 24-volt controller.
You are so good at describing our actions.
Thank you.
Okay.
Okay, so what is the meter connected to right now? Nothing. Okay.
Let's connect the meter to something though. Now, if we connected it to my brain, you'd see a lot of energy there. We're trying to share that energy with our project here. Okay, I guess now we haven't connected.
Do you want to? Let's measure the capacitors.
You want to go
Yeah.
with that? Okay.
Yeah.
So.
Will it? It's not gonna.
So I go here.
Will it discharge it?
No.
No.
Well, maybe very, very little, but.
Okay. For a spark.
It'll be interesting. No, it won't spark.
Okay.
So here is where we went in, and then here. So I'm gonna go here.
Careful.
Yep. Hang on to this thing, it's slippery. Okay, that should get us some voltage.
27.5.
Okay, I need to connect our motor. Well, we've got to connect the controller.
Oh, you didn't connect that yet.
Yeah, the controller.
Oh.
Oh, the controller. Yep, I gotta change this. It looks like I need to do that.
Is that wrong?
Yeah, we got another one.
Oh.
I made one up thinking we needed it, and
we have one.
we have one. So.
I'm just going to. Oh, I'll wait.
Okay, that's all right. Going into the controller, and we still have to connect the motor too. Where's the motor wires? Here's the motor wires. What are those?
Oh, the motor is disconnected?
Yeah.
Oh.
Let me connect it. I'll connect it right now. It goes to the controller.
Okay.
This is the motor. Motor goes to the controller as well. Right here.
Okay.
That's our motor. Okay, plugged in. Need to keep that away from those wires there. Okay. Let's bend this up a little
Now, we need to connect the controller to our capacitors.
Okay, the controller's right here. And we're going to go to the capacitor. These batteries are right there too. Let's see how we're doing this. Oh,
Wait a minute.
I need this one. I need this one. Yeah, you were saying?
I'm thinking.
I need this. Wait, is that the one I need? Yeah. Sure. This one should work. I can use this one. Has longer wires on it.
Oh.
Okay, I'll go in here to the controller. And we'll go in. No, wait, this is reversed. Uh-oh, okay, wait, I gotta make sure I get this. So this side's positive. Gosh, I don't know why the plugs are like this. See how it's reversed?
Yeah.
That's okay, we know that red's over here, so I'm going to red. Okay. We're just using what we have.
Yep.
If it, when we get it working, we'll then get all the colors correct.
Yeah.
For now, we just want to plug stuff in, see what it does. Okay, just keep trying and try. See what happens. That's a lot of plugs.
Well, I have a question. Do you
Yes.
think it's that there would be a problem if the capacitor, if the alternators were sending some of their energy to like the controller? Because you know how it's like all connected together.
Well, the capacitors might clean up the signal, actually.
Okay.
Yeah, that's a good point. Because the way we have it connected now,
okay, so
some
we
of
have everything through diodes, right? So it's all
does that
not-
do those clean it up? Diodes?
no. I'm just thinking about where the energy or where it's flowing.
Yeah, some of it's going directly to the controller, and some's going here.
So is that are we losing energy that way? Possibly.
Well, this reminds me. Now, I've never put one of these capacitors in a car, but when I was reading about it, it looked like they were using them this way for the car amplifiers back when they used to use these.
Yeah.
And it would just be connected, kind of what looked like this. I'm not sure if it's exactly though. And it would just keep it was meant to keep the voltage up.
So
That's at least what-
so you don't really know if that's
I don't really know what. I said yes.
yeah.
Yeah, I said yes. Some of it's going back.
But there's no controller in a car audio system, right?
I don't know what's in the car audio system.
I don't either.
Are you saying that you want to?
I'm just saying like if the like the alternators are flowing. Okay. I'm just trying to see where all the wires are. Okay. Can you show me where the controller wires are?
Right here.
Right there. Okay.
Right there.
Okay. So
some of it'll go there.
yeah. So what I'm saying is if it's getting divided, I don't know if that's a problem. Like if it's going to. Maybe it's not.
I see.
Maybe it is, maybe it's not. Maybe it doesn't matter, but
Well, I think the way we have these wired, it's acting like one big capacitor.
right.
So
I
look
understand
that's
that.
just one.
Yeah, I get that.
And to me, this is just floating the voltage. I don't know if that's the right words, but it's going to keep the voltage at a certain amount.
Mm-hmm.
The way it's connected. To me, what are you thinking? You want to try? I mean,
Well, I'm not talking about smoothing out the voltage or whatever. I'm not talking about that. I'm just
are you
talking
talking about trying to get this to go through here, and then on the other side we come out and give the controller?
Yeah, that's what I was.
How could we wire that way? I know what you mean.
Mm-hmm. I mean, maybe it doesn't matter, but maybe that's.
We could try it both ways too. But
I think we should try it like this.
Yeah, I do want to try to see how we could do that. I don't know right now.
Yeah.
I know what you mean. But
Yeah.
I like that too.
Okay.
I do like that.
Okay.
I just don't know how to do it.
Yeah, I got it. Okay, well, let's start with this, right?
Okay.
Okay, so we've got. Oops,
You just turned it off.
I turned it off.
No, it just turned one.
Oh, there we go. Okay.
All right, so we go ahead and see
so
what we got.
can I just set this here? Is that safe?
Yeah, it'll probably shake a lot, but we can see.
Oh, okay, let's see.
This whole thing vibrates like crazy.
Yeah, if it starts shaking too much, or if it is shaking too much, I'll lift it up. Okay. Alright.
Yep. All right, ready, guys?
Ready.
So,
Okay.
here we go.
Oh, you were gonna turn it on? Just turn it on, and then use the throttle. I thought we were doing it that way, right?
Oh, yes.
Oh wow! It's
Just
drawing just by turning it on. It's just look at it. Dropping.
Whoa, it ran off the capacitors.
That's cool.
I can't believe that. It's running just off the capacitors.
Okay, go.
Whoa.
It's not gonna run
For a
you.
second.
Yeah.
Okay, let's charge them up.
Okay.
I'm surprised it even ran at all.
Don't want to go too high. Oh, I guess it's dropping. I guess really fast.
Yeah, it's gonna drop fast.
Wow.
It may only run for a couple seconds.
All
Should
right.
I give it? Should I keep it going a little bit until keep the RPM up?
No.
Just
What
do-
are you
okay,
doing?
just do
just
that?
Do one at a time. Just
Okay.
One at a time. Okay. Go ahead. So
It's not doing
throttle.
anything.
We're gonna do throttle.
It's not doing anything.
We're not doing anything now.
That's weird. Let me try
That's
resetting.
strange. That's really weird.
Oh, because the voltage went too low. The controller has an automatic shut off.
It does.
Yep.
Oh.
Once the voltage goes down,
Oh, okay, all right.
it's gonna do it again. It
I
doesn't
see.
take much.
Okay, well,
We gotta charge them
You
back
gotta-
up. So this is
no,
off.
no, it's good now, right? Because
No,
the voltage dropped earlier, but I don't know if it once you just by charging it up, I don't know if that'll reset it. You might have to use the switch to reset it.
Okay.
Does that make sense?
Yeah.
Well, now it might not go. Yeah.
So shut this off. Charge them up.
So.
It seems like we should help it to see if it'll keep going, because it just drops too fast.
Yeah, I see.
Because we just want to see if it'll stay going, right? Isn't that what we're doing?
Yeah.
Okay.
Let me see. Can I move this? Unplug this. Oops. Okay.
I'll turn it on. Can I
Okay.
stop? Maybe I should stop and turn it on. Let's see.
I think you just gotta move fast. Oh, whoa.
Oops.
What happened?
It seemed like it tried to run backwards.
Oh.
Uh-oh, that's not good, is it?
What happened?
This is confusing. Let me try it again. I might have it hooked up wrong.
Okay, now
let's
try
see
it.
if this turns backwards or forwards. Oh, it's going the right way.
Okay.
That's weird. What it did that? Like it pulled the drill. Like it pulled the drill.
It pulled the drill?
Well, it acted like it wanted to turn a different way or something. I don't know.
Hmm.
But I was trying to help it. I was trying to help it stay going.
I see.
Let's see. Turn it on. Now I'm trying to help it keep the voltage in, but it did something weird last time I did that.
It's probably trying to stimulate it. I don't want to ruin the drill. Okay.
Trying to see if it'll run it by itself.
What was that?
I'm trying to see if it'll run by itself when I let off the drill.
Okay. Got it. So right now you're throttle?
Give me the throttle, yeah.
Okay. Okay,
I'm going to pull this off.
Okay, pull it. So that's...
Seems like it's shutting itself off. Let's see.
That's,
oh yeah, the light's flashing red.
It's, oh, yeah.
Maybe the controller's hot.
Well,
No?
that's high voltage for that controller, isn't it? It shouldn't be going up that high for that controller, I don't think. So that's probably why it was red.
I see what you're saying.
Yeah.
Over voltage. Okay.
Yeah.
Let's see. Yeah, I didn't think of that.
Yeah. Okay, well...
So it's shutting off before it gets too low. Let's see.
Okay. Do you remember how we tested the... gosh. Capacitors charged up, right? Before.
Yeah.
But it wasn't hooked in, like, the loop.
No. It was just the alternators to the capacitor, I think.
Okay, but you had, what, you had the drill in there? Okay, so the drill was really powering the...
Yeah, the drill was charging the...
Okay, well then, I guess that's not quite the same as the capacitors having been.
Okay, so we're having trouble because the voltage is just fluctuating too much, and the controller doesn't like it. Too high, too low.
Well, this is also...
Oh, I wanted to read the amps. Go ahead.
Yeah, this is just... it's dropping too fast. It's not gonna... I don't think the problem is the controller.
It's just dropping too fast. Okay.
But it should... I mean, technically, like, if we had this right, I feel like this should have stayed charging. That's how I feel about it, because it was able to get it going. And just by getting it going, it should have been able to just start, or just go. So, right now, it's not working.
Yeah.
So whatever, if we have it hooked up wrong, or I don't know. Alright, well you guys saw what we did with the wiring here and everything, and If you guys have ideas, if you have thoughts, we'd love to hear what your thoughts are. If you think there's any other way that we could try to get this to work.
Can I go over what Lance had said and just say that we didn't understand it in case he's still trying to help us?
What was he saying?
Okay, so Lance wrote us a comment on one of the videos, and he was saying, from what I understood, he was telling us to hook the alternator. You want to put the camera up here? He was telling us to hook, from what I understood, he was asking us to put the alternator, to connect the alternator to a bridge rectifier, and then to a capacitor, and then to the next alternator. And the reason that we're uncomfortable doing that is because if all these alternators are spinning and putting out voltage, if we send DC voltage into the output of AC, that doesn't make any sense to do that. So Lance, if we're misunderstanding you, please clarify.
Well, maybe would it convert it to AC though, coming back out?
Well, I mean, if you're plugging into a rectifier,
like the full wave bridge rectifier,
yeah,
would it be coming out? I think it might be coming out.
It would come out DC.
It would come out DC?
Yeah, that's what comes out of bridge rectifiers, DC.
But but going into it, I'm not 100% sure, I guess, because...
Well, that's what we have here.
But we have going into it of AC, right?
Yeah, but that's what comes out of these, AC. He's telling us to plug DC coming out of this into the... Unless he's saying something else.
I thought well... If you plug in...
You want me to read the comment? I'll get my iPad.
Sure, you can. I mean,
because if
what I'm saying is, it's not. It doesn't. The bridge rectifier is. You know how it doesn't matter on either side, like.
Yeah, you can
coming out.
Positive and negative.
Yeah, isn't that because would that be? Could that be AC? I don't know. No.
It's DC.
Okay.
DC comes out of this.
But you can put AC in. So I guess I'm confused. Why can you put AC in, but you can't have AC coming out?
Because they're made to the diodes.
Yeah.
Only let DC come out, from what I understand. That's what they do. The diodes don't let
Are you sure?
Well, from what I understand, from what I read, and from what I was told at the electronics store, the diode changes AC over to DC. And it acts like a valve that doesn't let anything come backwards. It just lets it go one way. Full wave bridge rectifier. Well, full wave.
Yeah, I see.
Full wave. What does that mean? Full wave in and then, I don't know. I'm just telling you what I was told and what I've read. It doesn't mean I understand it right. But let me go to Lance's. I don't even know where he wrote that comment at. I don't know which video that was. Let me see. I guess I could just start checking each video. I'll check each video. Okay, this looks like it might be the one. Take the output of the generator and feed it into a full... Yeah, so here it is. I don't know if I want to show that, but... So Lance was explaining to us that he said take the output of the generator and feed it into a full wave bridge rectifier, which is what we have. Feed output of the rectifier into a capacitor to be used as an electrical storage medium, which is like a battery. Mm-hmm. Feed the output of the capacitor into the next generator. But the thing is, the next generator has AC coming out of it. So that's, to me, that's like taking, plugging in plugging the capacitor into your wall. Like there's AC coming out of the wall. It would be dangerous to do that. Mm-hmm. That looks like it's dangerous to do to me. To me, this looks very dangerous.
Yeah, I see. Yeah.
I'm just not going to do that.
Yeah.
So I don't really understand what.
I don't really understand
what this
either.
means, what it is. It doesn't make sense to me.
Yeah.
If there's something there, great. Maybe I'll understand it someday. But I'm not going to plug the output of a capacitor into the output of a AC alternator.
The output or the input? Is it output?
Alternator is just, well, it's an
I guess.
output. There is no input for an alternator. Not for a permanent magnet alternator. Now, if it's a regular alternator, then you have the...
I see what you're saying.
Yeah, there's no
Yeah,
input
that's
on an
right.
alternator. I mean, this doesn't make any
Yeah,
sense
that
to me.
doesn't make sense. Yeah.
So, Lance, if you're trying to help us in this, maybe you said something wrong here, or we don't know something, but if you want to clarify for us, please do. But we're not going to do this.
Yeah, yeah.
That just doesn't feel right to me at all.
Okay,
It goes against everything that I've read.
I see.
So I'm still open to doing things that are beyond what we've read, but
Yeah.
this just doesn't make sense to me.
Yeah, I got what you're saying.
It says, I think this will help because the two coils of the two generators are not synchronized. I mean, that sounds good.
Well, yeah, I mean, I think if you have everything going into the I don't think you need to, the way he's saying to set it up, it doesn't make sense.
It
but
doesn't make sense.
I understand having everything going into the capacitor, but I don't understand the rest of it.
Yeah.
Yeah.
I mean, to me, it sounds like just get, like for example, all four of these alternators, whatever power they make all together,
Yeah.
getting a larger permanent magnet alternator that has the magnets and the coils inside that all four of those have
Yeah.
into one unit, and then run that into a bridge rectifier and that into a capacitor, and then that into whether it be batteries or directly to the
yeah.
controller or something.
Yeah.
So anyway, just letting Lance know that we don't understand this, Lance. It doesn't make sense
Yeah.
to do that.
Okay.
So anyway, if anyone else has any suggestions or ideas, please share.
Yes. Yeah. We're not sure what to. I don't know. I'm not sure what to do next. But if you guys have other ideas, definitely let us know. Anything else to add?
Is there any more tests we can do now?
I don't think so. If there are, I'm kind of wiped.
Okay.
So.
Yeah, I want to ride it. I just want to ride the scooter, so I might just ride it. Okay, I'm gonna end this stream, and the next stream just might be me riding the scooter, because I haven't ridden it yet since we put the alternators on it.
All right.
Haven't ridden it since we put the alternators on it. Just doing lots of bench testing, I could say. So thanks for joining us, and we will see you soon in the next stream.
All right. See you guys next time. Bye bye.
Thanks, everyone. Bye. If you have any suggestions or ideas on how we can hook this up, please do share in the comments area. Okay, have a great day. Bye.